Okay, welcome to the video on simplifying by combining like terms. This is our second example set B. And I'm going to make a couple assumptions here. One, that you at least watch the lesson and you understand how to combine like terms. Because remember, we're just practicing this. So if you don't really have an idea, I suggest you go back and watch the lesson. And it's probably a good idea to take a look at the first example set. Okay, so also you should understand what a coefficient is and a term, and obviously like terms. Okay, so let's go right to it. So what we want to do is simplify these expressions. In other words, we want to make them as simple as possible. So we have an expression here, for example, negative 7m plus 2m. And the question is there a simpler way to write this? And in fact, there is, okay? When you have two like terms, and these are like because they both have m to the first power, all right, you can combine them by simply adding the coefficients, and that's the numbers in front of the term. Okay, so negative 7 and 2 is going to be negative 5m. Okay, so we added the coefficients. All right, you can add the coefficients when the terms are like. All right, so this is the simplified version of that expression, and that's all we're doing here. So let's take a look at the next problem. And what we want to do is to identify like terms and constants. All right, so let's go ahead and see. We have an x here, a 1x. We have a 3x. So those are two terms. Now let's ask the question, are they like? All right, in fact, they are because they're both x to the first power. So we can write 4x. All right, and if you want, you can put one line through the terms like this just so you can keep track of what's going on. And now we have 4 and negative 9. Those are constants, and we can combine those into negative 5. And oftentimes, students understand the concept, but they go too fast, and they'll mess up on their integers. Okay, so take your time and write neat. Let's go to the next problem here. So we have a couple terms here. Remember, terms are separated by a plus or a minus sign. So we have negative 6ab and 10ab. And they're separated here by this addition operator. So the first question is, okay, we have two terms. Are they like terms? Right? They are, because they both have ab, and ab is to the first power on both of them. So therefore, we can simply combine the coefficients of these two terms. That would be 16ab. Right? So if this is not too challenging, that's good. And it's not too difficult. If you understand this, we're just practicing various problems. You're saying, well, I get this. I don't need to do the rest of the problems. Well, each one of these problems I kind of pick out just to have a little bit of different twist. So you see as many different possibilities with these type of problems. Okay, so hopefully this you won't be tripped up with this in the future. Okay, so we have three terms here. We have this one, and this one. So with these three terms, let's go ahead and identify any like terms, if there are any. Okay, they all have x, y's in them. Okay, this is x squared. Okay, this one has an x squared. This one has an x squared, but this one has a y to the first, but this one has a y to the second. These are not like terms. Okay, in order for these to be like terms, they have to be exactly alike. So therefore, you need to have two terms with x squared y or x squared y squared. Okay, and you can see here we don't have any two terms like this, or just one term in and of itself. So this doesn't have a like term. This middle term, if you look closely, does not have a like term, and the last term does not have a like term. So guess what? This is as simple as it can get. Right? You cannot combine any of these terms because they're not like. All right, moving on. That was kind of a bit of a trick problem, but hopefully you got it right. So the first thing here is to take a look at the situation. We got three terms here. Let's see if we can identify any like terms. Okay, we have y and a y. Okay, they're both y to the first, so we can add their coefficients. And you can see here they just go away because we're going to add 2 and a negative 2, and that's 0. So that just leaves us with this one term and this constant over here, 8. Okay, so we can just write the simplified expression 2y squared plus 8, and we're done. All right, moving on. Okay, we have t's here. T, 2t, and 4t. And after a while, you'll kind of get the hang of it. You'll be able to recognize these terms as being like. Okay, hopefully you can see that all three of these terms are like because they're all t to the first. So this is going to be 1t plus a 2t. That's 3t. Okay, so this is going to be, these two together are going to be 3t. 3t plus 4t is 7t. And if you want, you can go and put a line through that just so you can kind of keep track of what's going on. And now I just need to add my constants. The negative 10 plus a negative 3 is a negative 13. All right, let's take a look at the next problem here. Now, if you recall from the lesson, that sometimes in order to determine whether we have like terms or constants, we need to go ahead and remove any distributive property situation. Well, let me say that in a different way. If there is a distributive property situation, you don't remove it. You actually apply the distributive property. Okay. So instead of seeing the problem this way, let's go ahead and analyze the problem after we apply the distributive property. Now that's another way to rewrite this expression. So this is going to be 4w times w. 4w squared. Okay. Don't get that. Go back and take a look at the distributive property video. Now we have 4w plus 1, or excuse me, 4w times 1. So it's going to be plus 4w. And we have plus 6w. We're just going to rewrite the remainder of the expression. All right. And now we're going to go ahead and take a look at the terms. We have 4w squared, and I have a 6w squared. They're like terms. I have a 4w here. I have a minus w. Those are like terms. And then I'm left with a 8. All over here. Okay, so those are your situations. We have two like terms. Okay, two sets of like terms. So let's go and write those. Now, what you want to do here, this is something I'll talk about in later videos, but we'll bring it up now. I'm going to write the term with the highest power first. Okay, you want to get in the habit of doing that. So I'm going to write the w squared terms first. So 4w squared plus 6w squared is going to be 10w squared. Okay. Plus 4w plus a negative 1w. Okay, remember adding the coefficients, it's going to be 3w. All right. And then I'm just simply going to add in my constant. Now, so I have 10w squared plus 3w plus 8. I could have wrote 3w plus 10w squared plus 8. It wouldn't be wrong, but typically what we do is we go ahead and write the highest power first. All right. Okay, so let's go down. Let's take a look at this last problem here. And let's see here, I have a negative 3z, so I'm going to look for things with z's in them right now. Okay, I have another like term. Okay, so those two are like terms. I have an 8y as a term, so let's see, is there any more y's? Yes. So I can combine those two terms. Okay, I have a 5m. Is there anything else with an m in it? Yes. All right, so those are all my terms I have to combine. Now in this case, they're all at the same power, the power of 1, so it doesn't make a difference what order you write them in. So I'm just going to go from left to right. Negative 3z plus 1z, remember there's a 1 there, it's going to be negative 2z. Can I cross cancel them just so I can kind of keep track of what's going on? 8w plus 8y plus a negative 2y is going to be plus 6y. Cross cancel those. Now I have 5m plus a negative 1m. That'd be plus 4m. Okay. All right, so if you're getting the hang of this, I congratulate you. This is an important skill that you'll need to have in your study of algebra and beyond. So, like I said, if you're getting this down, that's great. I hope to see you in the next video so we can do some more challenging problems. Thank you.